In today's session, we shall discuss the concepts of statistics in detail. Statistical knowledge helps you use the proper methods to collect and present the data, employ correct analysis, and effectively present the results. Suppose I want to know the number of fiction and novel books in a library. What can I do for that? I arrange all the books in the library to different categories like stories, fiction, novels, drama, etc. to get the count of each of the classification. Let's discuss the concepts of statistics to get started with group data. If there are x1, x2, xn number of observations and f1, f2 which goes up till fn are the respective frequencies, then the sum of all the values of the observations are f1 x1 plus f2 x2 plus which goes up till fn xn, and the number of observations are f1 plus f2 which goes up till fn. So the mean x bar of the data is given by f1 x1 plus f2 x2 which goes up till fn xn, which is divided by f1 plus f2 which goes up till fn, and the summation is written in Greek letter sigma. Therefore, x bar is given by sigma I is equal to 1 to n fi xi divided by sigma I is equal to 1 to n fi. Let's now consider an example of marks obtained by 30 students in class 10. Here, marks obtained is written as xi, fi as number of students, product of xi and fi and summation of the same need to be calculated for further analysis. Therefore, the mean x bar is given by sigma fi xi divided by sigma fi giving you 59.3. Therefore, the mean obtained is 59.3. From the previous tabular column, we understand that the class interval of marks starts from 10. Therefore, we start our class interval allocation from 10. Let's choose a class interval range. Here, class interval is equal to 15. While allocating frequencies to each of the class interval, students falling in any upper class limit would be considered in the next class interval. Here, students have scored 40 marks. In which class interval do you consider writing them? 25 to 40 or 40 to 55? By convention, always write them in the next class interval, that is 40 to 55. Frequency of each class interval is centered around its midpoint called as class mark. Therefore, class mark is given by the summation of upper class limit plus lower class limit divided by 2. For class interval 10 to 25, you get as 17.5. Similarly, find the remaining class marks using the above method. Let's represent it in tabular form. Let's find the x bar from the data. X bar is given by sigma fi xi divided by sigma fi, which gives you 62. This new method of finding mean is called the direct method. Now, we have two means using the same calculation method, which is solved one with no class interval and one solved with specific class interval, that is 59.3 and 62. Which do you think is more accurate, 59.3 or 62? Let us now think a method of reducing all these calculations. The first step is to choose one among the xi's as the assumed mean and denote it by A. Since there are even number of class marks, do we choose 47.5 or 62.5? Let's choose A is equal to 47.5. The next step is that to find the difference between A and each of the class mark and denote the difference as di. That is, di gives you xi minus A, that intends to give you xi minus 47.5. We call this as deviation from each of the xi's. The third step is to find the product of di with the corresponding fi and take the sum of all the fi di's. Therefore, the mean of the deviation is given by d bar is equal to sigma fi di divided by sigma fi. di can intend to be written as xi minus A. So, d bar is equal to sigma fi in brackets xi minus a divided by sigma fi. Now let's multiply the products. D bar is equal to sigma fi xi minus sigma fi a to the whole divided by sigma fi. Now let's split the equation. D bar is equal to sigma fi xi divided by sigma fi minus sigma fi a divided by sigma fi. We know that sigma fi xi divided by sigma fi can be written as x bar, that is the mean. Therefore, D bar is equal to x bar minus sigma fi a divided by sigma fi. Cancelling out the common numerators and denominator, we get D bar is equal to x bar minus a. Rearranging the equation, we get x bar is equal to a plus D bar. D bar can again be written as sigma fi di divided by sigma fi. Therefore, we get x bar is equal to a plus sigma fi di divided by sigma fi. Substituting the values of sigma fi di and sigma fi from the table, we get 62. Therefore, the mean of the marks obtained by the students is 62. This method of analyzing the mean is called the assumed mean method. Let's consider another example of 30 students whose class interval are in the range 10 to 100. Calculate class mark xi and products xi fi, which accounts for direct method to calculate the mean. Now, let's observe the table of assumed mean method. Note that in column 4 we have multiples of 15. Therefore, if we divide the entire column by 15, we should be getting smaller number to multiply with fi. So, let ui is equal to xi minus a divided by h, where a is the assumed mean and h is the class size. Now, let's calculate ui according to the above equation. Now, let's add another new column multiplying fi and ui. Let us assume u bar is equal to sigma fi ui divided by sigma fi. Now, what is the relation between u bar and x bar? Let's find that out. We know that ui is equal to xi minus a divided by h. Therefore, u bar is equal to sigma fi in brackets xi minus a divided by h to the whole divided by sigma fi. Let's keep h outside the brackets and multiply the numerators. That is, u bar is equal to 1 by h in brackets sigma fi xi minus sigma fi a divide the whole by sigma fi, which gives you u bar is equal to 1 by h in brackets sigma fi xi divided by sigma fi minus a sigma fi divided by sigma fi, which implies u bar is equal to 1 by h in brackets x bar minus a. Now, let us rearrange the equation. That is, h u bar is equal to x bar minus a, which gives you x bar is equal to a plus h u bar. Now, let us substitute the value of u bar. That is, x bar is equal to a plus h in brackets sigma fi ui divided by sigma fi. Now, let us substitute the values of a, h, sigma fi ui and sigma fi from the table. We obtain x bar is equal to 47.5 plus 15 multiplied by 29 divided by 30. That is, x bar is equal to 47.5 plus 14.5, giving you 62. The method discussed above is called the step deviation method. Step deviation method is convenient only when all the di's, that is the difference, have a common factor. Also, the mean obtained by all the methods are the same. Now, let's solve an example solving it in 3 methods. Let's consider a table providing percentage distribution of female teachers in primary schools in different states. In the table, you see that there are 15 to 25% of female teachers in 6 states and 25 to 35 in 11 states and so on. Now, let us find the class marks of each class interval. Class marks is given by the sum of upper class limit plus the lower class limit, divide the whole by 2. Solving the same, we get the class marks as 20, 30, 40, 50, 60, 70 and 80. Here we take A is equal to 50 as that is the middlemost class mark and H is equal to 10 as that is the difference between each of the class interval. Therefore, di is given by di is equal to xi minus 50 and ui is equal to xi minus 50 divide the whole by 10. Now, let us find di and put them in the table. From the table, we obtain sigma fi is equal to 35, sigma fi xi is equal to 1390, sigma fi di is equal to minus 360 and sigma fi ui is equal to minus 36. Solving it in direct method equation, we get x bar is equal to 39.71. Coming to assumed mean method, we get x bar is equal to again 39.71 and step deviation method again we get 39.71. Therefore, the mean percentage of female teachers in primary school of the number of states is 39.71. The mean for group data can be found by direct method, assumed mean method and step deviation method. The formulas for the same are x bar is equal to sigma fi xi divided by sigma fi and assumed mean method is given by x bar is equal to a plus sigma fi di divided by sigma fi and step deviation method is given by x bar is equal to a plus h in bracket sigma fi ui divided by sigma fi.